Good morning, students. Welcome to revision 2, video 2 of this revision 2 section of refraction of light at curved surfaces. And from May 27th, these classes, this chapter or this unit classes started, and videos are being uploaded. And how many of you have watched the videos? How many know the concept? If you have watched the videos also, maybe there is a chance of forgetting some of the concepts. So let us take some of the concepts. Let us revise this one. So here, refraction of light. Reflection is over, and see, many methods are there. With many phenomena is there: reflection, refraction, interference, polarization, diffraction, Crompton effect, photoelectric effect. Like that, many procedures are there. Many phenomena are there. And this refraction is also one of the property of light. So what happens in this one is the light, when it is traveling from one medium to another medium. So what happens due to its change in velocity? Whose velocity? Change of velocity of the light. When the light is traveling from one medium to another medium, air to water, example. So in the light, in the air, the velocity of light is very high, 3 into 10 to the power, approximately 3 into 10 to the power of 8 meters per second. So when it enters into the water, its velocity decreases. A cycle motorist is coming very fastly, 60 kilometers per hour. Suddenly he got a speed breaker. When he applies the brakes, sudden brakes, what happens? The tires will skid. That means this direction will change. So instead of going straight, he will come like this, or he will go like this. So similarly, this light, when it is coming with that much speed, when an obstacle is coming like this, whatever the air, so due to change its velocity, the light starts refraction, that is bending to away from the normal or towards the normal. How it will bend? Let us see. The plane surface. This is normal. Okay. Suppose think this is air. Air is one medium, and water is another medium. Now air is traveling from air, that is nothing but light is traveling from air to water. This is incident ray. Now this is coming and hitting here. This is point of incidence. And when it is traveling from rarer medium, air is a rarer medium. That means the density of air is less than the density of water. That's why air is considered as rarer medium, and is considered as denser medium. What happens? Due to change in velocity, it bends towards the normal. Now see, the angle between this incident ray and the normal. This is normal, and this is called angle of incidence, or I. And if you compare this angle of reflection, both are the same. Here you see here, by seeing only we can say this angle of reflection, angle of refraction, not reflection, refraction. Angle of refraction is less than angle of incidence. So angle of incidence, otherwise we can say angle of incidence is greater than angle of refraction when the light is traveling from rarer medium to denser medium. Okay. Converse means reverse, opposite this one. Consider that the light is traveling from denser medium to rarer medium in a plane surface only. Plane we are talking about, plane surface. So light is coming from like this. Here. This is angle of incident now. Angle of incident. This becomes angle of refraction. Now see angle of refraction. Now see angle of incident, angle of refraction. Here angle of incidence is given here L, and angle of refraction is given here. Now by seeing we can understand that when the light is traveling from denser medium, that is D or water, and going into the rarer medium, so this angle is compared to the angle of refraction. So that means when the light is traveling, it is bending away from the normal. When the light is traveling from denser medium to rarer medium, it is bending away from the normal. See, away from the normal. And when it is traveling rarer to the denser, bending towards the normal. Both the angles are not same. If the both angles are same, angle I and angle are same, that means two angles are same, then that becomes reflection, regular reflection. Angle that is reflected, not refraction. You get reflection. Here we can say that angle of incident is less than angle of refraction when the light is traveling from denser medium to rarer medium. Is this happening in the case of spherical mirrors also? That is the question. This is happening. So for that one, he has given some red diagrams. So curved surface red diagrams are given, which is rarer medium. One black side will be given in the textbook, page number 58. In the textbook, to make you understand, he has given some colors. And white part he considered as rarer medium, and whatever the dark part and the polished dark part is considered as. For example, I will give one example. As we have less time, so this like this they have given one example, and he told that this is air. White paper is white, no? This is air, and this is water. This is water, and he has quoted everything like this. With black is ash black or black. So their names is a denser medium and this is rarer medium. Why? What is a rarer medium? There is the medium whose density is less compared to that of another medium is rarer medium and denser medium. So what happens when light is passing? We can say when the light is coming, that one ray that is over here that will be going straight, and when the third surface is in the parallel to the principal axis, after coming here, it will go like this. And if I stretch like this back, they will come and meet at one point, that is called focus. That is different. Or center of curvature. If I take the normal should be taken equal. See from here, and that normal will come and meet, and that forms center of curvature. And here angle of incidence and angle of refraction will be there, and both will be same. And here two cases will be there. One is concave surface, one is convex surface. Concave surface and convex surface. What we see? Let us talk about concave surface. When the light is traveling from rarer medium to denser medium, in the case of convex surface, so when it is traveling through the center of curvature, it will not deviate. So that means this is the medium. So here F is there, focus, and this is the center. And when the light ray is traveling like this, coming in the path of this one, will not deviate. That means will not bend. That is the first thing we have to remember. That is the nature of the light. When it is traveling parallel to the principal axis, after refraction, it will bend somewhere and meet on the principal axis. So this bending up of light rays when they are traveling from one medium to another medium is called refraction. Refraction of light. Now, which side it is bending? If I draw a normal, how to draw normal? Means first you draw a tangent to this point or curve. After drawing a tangent, so we can draw like this. From this one, if you draw, this is the normal, and if you draw the normal from here, this normal will come and meet at one point, and the meeting point of normal is called center of curvature, and that will decide that the light is parallel to the principal axis. After refraction, not going straight, it has to go straight. Instead of going straight, it is deviating the path. It is bending towards the star. If this is thick, I am talking about thin surfaces. We are talking in this total chapter about thin surfaces. If it is thick surface, still it will bend. Still like that. If the surface is thick, the bending power will be more. That bending power is called refractive index. Simply we can say the bending power of a lens is called refractive index. Here 4 cases are there. So try to draw the 4 cases in your book, and image formula is there. Image formula N2 by V minus N1 by U is equal to N2 minus N1 by R. This formula N2 by V minus N1 by U is equal to N2 minus N1 by R. This formula the is called curved surface form of curved surfaces in refraction. So on this formula there will be a question. So here this is the refractive index of second medium, N1 is the refractive index of first medium, V is nothing but the image distance, and U is nothing but objective distance, and N2 R is nothing but radius of curvature of that particular lens or particular curved surface. And after that we have some example problems you should solve in your textbook. Do one time, second time, third time. So don't think that the same values will be given. There may be if the same question comes, the values will be changed. If the values are changed, you will write this value will be given. Whatever the value is there in the textbook, that also will be given. Simply without reading, you will keep the same answer which is there in textbook, but there the values are changed now. With respect to that, the answer will be different. So that's why don't do blunder mistakes. Blunder mistake means without reading the question, some people what they will write the answers. Don't do like this. So same if this comes in case of plane mirror, 1 by r becomes 0. 1 by r becomes 0 means this total becomes 0. Then this is the curved surface formula. In the case of plane surface I am talking, plane surface, what happens? This total value becomes 0. How it will become 0 means I am just extend like this, n2 by v minus n1 by u is equal to I write n2 minus n1 into 1 by r. This 1 by r is 0. When this is 0, what happens? 0 into anything will be 0. So therefore, n2 by v minus n1 by u is equal to 0. 0 into v is 0. So therefore, n2 by v is equal to n1 by u. This is for plane mirror. Plane mirror and curved mirrors are there. So, and coming to after this one, he got about the lenses. So, what is lens means? Simply speaking, lens is a refractive medium. Means the lens, it means it is surrounded by two surfaces, two spheres, two spherical type of spheres. One is example I take one. This is one sphere. Okay. And another sphere has overlap, like a Venn diagram will draw insects. If I cut this part, if I remove this part from here to here, if I remove this part from here to here, then this is bulged outside here and this is bulged outside here, and this is called double convex lens or biconvex lens, or that is called converging lens. Converging lens or double convex lens. Double side convex, both side convex. And next one is double convex, biconvex. Bi means two side, bi means two, and double convex means two. If I draw, how should I find the center of this one? In the mirrors, curve is there. Then the geometric center means total from this one from here we will count with the help of head, and in that one the middle point will be geometric center. And here if I draw a perpendicular like this, okay. Next, if I from this center, geometric center, if I draw a line, the meeting point of these two is called optic center, and you notice where the O actually optic center of this one. So similarly, we are having another type of lens. This is another type of lens. Similarly, we have to draw, and this is the optic center for the O. Two lenses are also given. So these two are main important concepts introduced in our textbook. And the symbol of this lens is given as like this, two side arrows. When you are drawing ray diagrams, better to write the symbol of this lens. By in the place of this bulged surface, so you cannot write accurately. Just to draw a straight line and keep the arrows. This is the symbol of biconvex lens or convex lens anna biconvex lens anna okate. So convex lens ante interpretation, this is the symbol. Next way, when we are going for this kind of lens, keep the symbol, use the symbol like this, so that you can find easily optic center O. Here also optic center O, F1. See, for these lenses we have two foci. Focus means one. In the previous chapter, focus, capital F we wrote. Here we have two foci, means two focus will be there, and there is one this side F1 or this is F2, and two center of curvature. Why? Because it has two spheres. This sphere has C1, suppose this is C2, and if we join this one and this one, this will become optic center, and from here you have suppose F1 and F2, like this, two foci, two center of curvatures. If two center of curvatures are there, two radii of curvature. Radii is the plural form of radius of curvature. Okay, so like this we will be having, that is different and this is different. So there only one center of curvature, only one focus in the mirror, but here two foci, two center of curvatures, two radii of curvatures, and two focal lengths, small f1 and f2. Two focal lengths will be there. And apart from these lenses, we are having another double convex lens and double concave lens. Double concave lens, and this is gone inside, concave, and this is convex. Read from left. Concavo convex lens. You have to read from this side. Read from this side. ABCD you write like this. No. Read from this side. So concavo convex. That means this side is concave and this side is convex. That's why it is called concavo convex lens. So much depth is not given about this lens. Similarly, another one, convex. This is concave. We can read from this side only. Convexo concave lens. Convexo concave lens. You remember this one. Read from this side only. And next, one side plane will be there, plane, and other side wall inside. That is nothing but this. So plano concave. Convexo concave. Plano concave lens. See, plano concave lens and plano concave. So like this you will be getting 6 lenses are there. Apart from that one, 2 are very important. One is convex, biconvex lens, and the one is biconcave lenses. Their diagrams are given for that one with the help of lenses are given with the help of this one also given. See how it has been given. This is convex lens, symbol of convex lens, and this optic center. So these two, see that the distance from O to F1. Suppose this is F1 is here, F1 or F2, F1 and F2. Next one is C1 and C2. Now light rays are coming from this way. Example. Okay, 1, 2, 3 light rays. This is the 4th light. Now after traveling, it is a refractive medium. When it is traveling, so they will bend. They come and they will bend like this, and this is R, and these are they will bend here, this like this, and they will go like this. Like this. Now all they are meeting at one point. That's why this lens is called convergent lens. Converging lens are convergent lens. So and remaining other, in other case, so they will go away. As we told, they will go away. So try to draw the diagrams. You will get some half in the after that situation and behavior of rays, how they are behaving when they are passing. First thing is ray passing along the principal axis. So will not deviate if it is passing along the, that is ray. when it is traveling along the principal axis like this, will not deviate. That will not deviate. That means that will not bend. And another second situation is saying that this is optic center O. Light traveling through the optic center. This is along the principal axis will not deviate. Light ray traveling through the optic center of a lens does not deviate. Next, third one, light traveling parallel to the principal axis, like parallel to the principal axis of the lens. After hitting this lens, it will bend towards the principal axis and meets at the focus. And in the case of other, so they will go away from each other as if they are coming from only one point source. Focal vision, focus, principal focus, where is perpendicularly, not horizontally. Remember this point. And after that, we are having some rules to draw the ray diagrams. 5 rules are there. 5 important rules are there. I will read for you. Select a point placed on the principal axis. You have to select a point, whether it is beyond C, whether it is at C, whether it is between C and F2, whether it is at F2 or it is between F and C. Select a point on the principal axis. First, you select a point and draw a ray diagram above the principal axis. Draw the ray. After drawing the ray, extend the ray. That is the thing. If you have drawn like this, extend from here. Extend the ray like this, parallel to the principal axis until it touches the lens. Next, extend the rays and let them extend. After the reflection also, extend them until they both meet at one point. See how they are meeting with the principal axis until they both meet at principal axis. Then automatically you get the image. So after that we are having ray diagrams when the object is placed at infinity. Next one is when the object is beyond center of curvature, when the object is placed on the center of curvature or at the center of curvature, when the object is placed between the center of curvature and focus, principal focus, and when the object is placed on the focus, and when the object is placed between focus and the optic center. So what is there? This one. In only one condition, when the object is here in this position, in between F and O, the image will form like this. That is the virtual image. Two types of images are there: real image and virtual image. You know this one. Once again I will repeat. So the image which can be caught on the screen, is called real image. The image which cannot be caught on the screen is called virtual image. Always virtual image. Suppose this is the object. Image will form back side of the object. That is a enlarged, virtual, and erect. That means stage. So that is not inverted image. So remaining after that we have, this is the convex mirror. We are talking about convex. 6 in the mirrors we have drawn 6 diagrams of concave mirrors. Here in the lens we have drawn 6 ray diagrams of convex lens. So that means in the mirror, convex mirror is there. No, for that one, wherever you give the object, the image will form between F and P. There. Here, where in the concave mirror, suppose if we use concave mirror here, wherever you give the object, the image forms here. Virtual, diminished, highly diminished. Sometimes it is pointed image. Pointed image means we cannot say the nature of the image. And some example problems are there. Incomplete problems are there. Incomplete ray diagrams. Problems in the sense ray diagrams are there. After that, lens formula, and after that we are having lens formula is nothing but same here. Mirror formula and lens formula. Mirror formula is nothing but already 1 by f is equal to 1 by v plus 1 by u, and here 1 by f is equal to 1 by v minus 1 by u. This is for lens. This is for mirror. And magnification is same. M is equal to 1 by f for all the lenses, and 1 is equal to 1 plus. In this one, magnification derivation is there, and this mirror equation, that is lens formula or lens equation, this derivation is there, curved surface derivation is there, and lastly we are having one activity. The activity says like this: when you take a lens in and see the object in air through the air, that is, if you see an object from the air, lens in air, that will give you one type of image. And if the same object is placed in water, and if you see that object by keeping the lens holder, that means suppose the length is keeping the length, focal length, that is the length between the object and the lens equal to the focal length of the object, then that object appears to be larger. If you raise it up, it becomes larger, still larger, still larger. At one point, the object becomes such a big magnified such that we can see only part of the object. Says like that means by this activity he is going to explain you the refractive index of the medium depends upon the surrounding. The refractive index of the medium depends upon the surrounding media. So he is going to explain like this: in water it will behave different, in air it behaves different, in kerosene, naphtha, you take any solution. So that means the refractive index changes with the surrounding media. That he want to tell you. So with the help of one experiment he explained, and some problems are there. Back side of the textbook, and total column is there. What happens when the object is placed in infinity? So tabular column is there. In this back side also we are having what we have learned points. Again I am telling you, same thing should be followed, but how you have followed that chapter. Same thing should be followed. Write the subheading and write this one and equation. This equation also we can write. How we have wrote that one? 1 by f is equal to 1 by v minus 1 by u. So try to do your take LCM. V cancel. U minus V you get 1 by f. Now if you want f is equal to V into U divided by U minus V. This is the formula in the lenses. That is the mirror. This is the lenses. So image distance into object distance divided by object distance minus image distance will give you the focal length of that particular substance. So like that we can go on simplify the formula so that we get the answers. Not only this one. So go on reading the textbook. So multiple times, 2, 3 times, 4 times. Watch the videos. Okay. Write the exams very carefully. So then maybe changing values. I am telling you. Don't think that the values will be same and backside we can write without reading question. We can write the answers. Many wrote the worksheets like that only. Without reading the question, simply without watching the video also, we wrote. I think not many. Few people wrote by seeing this one. Maximum students wrote like that. We have seen. And this time, attendance is very important, and these exams are also very important. Until the physical classes are started, so online classes are not there. Please don't give up. Join the meetings, Zoom classes meetings, and join the interactions with the teachers, and complete the classworks at your home. And be safe. And if you have any doubts, you can contact us. We will be with you always. Thank you. Have a nice day.